Hey guys, it's Nicholas Gilbert. I'm the inventor of EcoMech 1. We're out here in a vacant lot here just to kind of demonstrate EcoMech 1 here. We're going to hook some different items into it, different home items, and pull some juice off of it and just kind of show you what it does. So we're going to roll the machine around. It's on casters. We'll do a turnaround on it. The purpose of doing this, guys, is so we can show that there's no smoke and mirrors. We don't have any hidden wires or anything on it. It's a self-contained unit here. We've got it on wheels. We're going to roll it back here a little ways and lock the caster back in if we can. Just lock it back down. Yeah, we'll lock it in so it don't roll. And so we're going to plug up these devices. So what we've got out here, we've got a couple of laptops. We've got a fan, just some common household items that we're going to power. We've got a light. We're going to demo a saw here in a minute too. Let's see if we got this thing far. Yeah, we should have enough room to plug into this thing. So this is a 4,000 watt output power inverter. It works just like any other power inverter. It works off a DC current. We've got 12 volts of battery bank that we're powering through the power inverter, which gives us electricity to power all of our home products here. So we're going to switch this bad boy on. And if you want me to go ahead and explain in here before we show what we're powering back here, we can do that. Okay, so in a nutshell, what we're doing is we're putting power either by solar or by mechanical, like this. This is the easy way to show it. So what we're doing is we're loading potential energy into a spring. Potential energy is the energy that's stored before it's released, okay? And then when we release it through what we call a gearbox, okay? Which is just a series of gears that's gonna make it turn faster at one end than it does the other. So to demonstrate that, we've put a little power into the spring. When this turns, it's turning the spring, which is turning the gearbox. And so the gearbox is now turning the windmill generator, okay? So, and I'm gonna stop this for a second. By spinning the windmill generator, it's just like a wind turbine, only we're not turning it with wind, we're turning it with potential energy of the spring. So as we're turning the generator, it's creating electricity to store into this battery bank here, okay? So the battery bank then, like I said, just goes from 12 volt DC to 110 AC. And that's what we've got plugged up right here on the household common items there for the house. Now, we're gonna disconnect the solar panels because there's a misconception that it's just a solar generator. In reality, it is a solar assisted generator. So rather than me having to come and wind it up manually, we can use the sun and let it wind it up and calibrate the spring force, put potential energy back on the spring. So that's the purpose of this. We don't really need this. As a matter of fact, we're going to go ahead and shut it off. So we're going to unhook the solar because we don't really necessarily need it. You know, this is if you want to be lazy and you don't want to wind it yourself, this is here to help. So here's our positive connector on the solar panel here. This is our negative. So we've got that got ready. We'll just leave them hanging out here. You can show in here where they go if you want to, Mike, for anybody that wants to know where it's going. It's going to what they call a charge controller, and that just keeps from overcharging your battery bank. So if there's too much sun one day, instead of blowing your batteries, this thing keeps it, you know, it discharges for you so it doesn't do that. All right, so we got our system hooked up here. I think everything is good. You want to show what our output is right here too, Mike?
Yes.
Because this might be some questions people is having. So this is a nice little power inverter that we picked up. It's pure sin wave, which is in our you know, what do you call it, in our experiments, I guess you'd say, that has been one of the better ones instead of a square sin wave. This ain't gonna help us a bit. So say if we're in a bunker situation or a storm and maybe the solar panel's broke, we can still wind it up in one of two ways. So the way the patent is set up, we've got what they call a first gear combination, which is this one right here. So we can actually manually input. And like I was telling Mike earlier, this is a short leverage. If we had a folding lever that was really long, a 3-year-old kid could wind it. You know what I'm saying? Because the leverage is in our favor the longer that it is. And so we can wind this thing up, okay, by hand. And when we wind it up by hand, we've got a brake over here to keep, because like I said, this is a dangerous situation to be into. You're not supposed to be in it unless you're a trained professional and knows what's going on, because there's pinch hazards and electric shock hazards in here. So when we undo the brake, okay, and I put X amount of torque in it, which is about 800 pounds. So I just exceeded 800 pounds, and so now we're starting to show energy from the potential, from the spring. So that potential energy has now been transferred through the gearbox and into the wind turbine. And so, as we all know, when a wind turbine turns, we're making electricity. So once we make the electricity here, and this is all else fails situation. You have no electric nowhere, like right here. We have no electric around anywhere, so we're having to make our own electric. Okay, so we wind this thing up. Now we're taking potential energy, making raw electricity through, I don't know if you can see it or not right here, Mike.
Yep.
The wind turbine. So it's turning. All right. And that's with me winding. Or we can also do it this way. So this is the first gear combo. And let me know if I'm going too fast, Mike. I'm trying to do this.
No, you're doing well.
So this is the second gear combo. Okay. If all else fails, say for instance your spring breaks. Okay. And so now you can't load the spring with potential energy, but you still need a way to turn the generator. Okay, so we've got 3 ways to do it. We can do it by solar, we can do it from the first gear combo, which feeds off the spring, and then we can also do it manually by hand here. And so we're doing the same thing as the spring's doing, only we're having to do it. Okay, and so we're sitting here having to wind the machine ourselves, but we're still making electricity to charge the battery bank. So we're not going to be without electric no matter what. This is fail-safe, all else fails way to make electric. Okay. Now, one thing I forgot to show you, I'm gonna hook the solar panel back up just real quick, because I forgot to show you this.
Yeah, so we'll show with the actual function of the solar panel.
Right. Yeah,
so it doesn't provide power to output to devices. It provides power to automatically reset that spring instead of having to manually.
Right. And but you can also use the solar too, if all else fails, like say your spring broke and your arm broke. You know what I mean? I'm just giving you scenarios, and you may have to rely just on the solar panel. It will still feed your battery bank to feed your products. Its main action, though, if you'll come over here, we've got an override switch right here. Okay, this is hooked up to a little winch motor, basically. That's also hooked to what I call a calibrator, and all it does is wind the spring back up. It's going to load the spring back up. So now the solar panel is going to load it. So we're going to go ahead and put input on the spring. I've got it unlocked over here so it'll turn when it gets the right pressure. So just by using the solar energy, we're turning that spring and putting energy back into the spring. So now we're creating electric again. We used 1.4 volts roughly to put pressure on the spring, but we're turning a 12-volt generator, and it's going through a semi-diode, which is going back to a DC. So it's going from, this is AC generator. It's going from AC, being rectified into DC, being rectified into AC through the inverter, and that's the stage order. Oh, there we go.
There we go.
So we got that going. Does this need to turn, or is it good the way it is? That's blowing some good cool air on us, which we need.
Good.
It's hot today.
Okay, all right, and so I'm just going to kind of come around and pan around the device just to show that the only thing that we have connected to this is this extension cord. Right, so this is the only thing that we have plugged directly into it, and we can I think you want to kind of move this around.
We want to dispel any smoke and mirrors here. This is a self-contained unit. It's the only unit that we're aware of in our patents that it has a built-in charging station. I can help him turn it.
Okay, you want to help him turn it? Yeah.
Yeah, we're just wanting to show, like I said, we're just going to wheel it around here in the parking lot. You can look under it if you want to, Mike. I mean, I don't know if that's important or not, but look under it and show, there's no wires, nothing hidden under there. We're turning the machine around so we can actually show that we're rolling it around. There's no hidden,
Yeah, just the extension cord, right? So there ain't nothing.
To that.
And the extension cord runs up
it down here
to this surge protector. Well, it's just a surge protector cord that's powering all of these devices that we have here, just normal household appliances, 2 gaming laptops, a monitor connected to one of the laptops, an alarm clock, an LED light, and a fan to keep us cool.
Yeah, and that's just a 4,000 watt model, guys. We could, this thing is scalable. According to our engineers, there is no cap other than a financial cap. We can make this thing the size of a train, and the bigger we go with this machine, the more energy we're going to put out. You know what I'm saying?
So we've been running these appliances, 2 laptops, 2 gaming laptops, a monitor, an alarm clock, an LED light, and a fan for an hour and a half. We've only been videoing for about an hour, but we've been running them for about an hour and a half off of the device without resetting, and we're at about 50% capacity for the battery, but we don't want the battery to reach 0. So what we're going to go ahead and do now is we're going to showcase how to reset this to start recharging the battery.
Okay. So since we're not going to charge the battery bank,
where the battery.
oh, the level of the battery, I don't know if you
Yeah.
show it.
Come back and
Okay, so it's like in the yellow, it's around 50% discharged.
Yep.
I'm glad they built that feature in there because it's pretty nice.
Yeah, it is pretty nice.
So in a scenario, typically it wouldn't even get in this, it wouldn't get in the red or the orange or the yellow. We typically want it to stay in the green. And the reason why is because the more you discharge off that battery, the more work you're going to have to put back into the machine to get it back to green.
at least for the prototype.
For the prototype, yeah.
Yep.
And so, like I said, we could hook this back up, and within about 3 hours, from where it's at now, it'd be completely in the green again. But we're going to demonstrate what it's going to take to recharge it manually. Is that what we're doing?
Yep.
So we're going to charge it manually just by cranking the wind turbine. And so anybody that knows what a wind turbine is knows it's going to take some effort, but this is a fail-safe unit to where, what if there is no wind, what if there's no sun? Now we can crank it and charge it up. And what you'll notice, I'll go ahead and point it out too, because I seen this the other day. When I start cranking this, the electric that's made is going to kick this battery on. So it's not on now. It's going to go ahead and start showing us a readout when I crank it. Let's see. It may take it a minute, but there it goes. So now we're putting energy back into the battery. Yeah, we're in the green.
Yep, battery's back in the green. So
Less than 3 minutes or so of winding, we went from yellow to green.
Yeah, this is why we put the solar panel on it, is so that we wouldn't have to sit here and work our hind end off. Just, you know what I'm saying?
Yeah,
kind of let
so
the sun
that
do it for us.
yeah.
You know what I mean?
So, and now in later models too, it'll
Yeah.
be possible that even when the sun's not in use, that we could use that logic controller to feed
Oh yeah.
power into the battery bank that's specifically utilized to rewind that.
Rewind it. Yeah.
So we wouldn't even need the solar panel. You
No.
wouldn't even need another the power that it's generating is
Right.
going to reset itself.
Uh-huh. Yeah, that's it in a nutshell. I mean, that's as easy as we can explain it. As far as Alpha Model 1 be a whole lot lighter, okay? Product Design Experts is designed it to where it's going to be way lighter. This machine weighs 550 pounds right now. My fault, because we didn't take into consideration the weight of the machine. We just want it to work, okay? Also, it's not going to have any of this in here, okay? The Alpha Model is not going to have a chain and sprocket system in it. It's actually going to have a really nice custom, what they call a transmission inside, just like in a vehicle. It'll be a transmission in here. The spring in this one is this whole machine is not very efficient, okay? It works, and we can prove its concept. It's not efficient. The spring that the Product Design Experts has designed for us, we wind it one time, whether it hits with the switch or we wind it manually, we wind it up until it's fully wound, which will take you about 10 minutes, guesstimation 10 minutes, and not much longer than that. But it's going to take an hour and a half, 2 hours to unwind, okay? And during that time, it's going to fully charge your battery bank. So you're going to wind it one time, okay, with probably less than 3 volts of electricity, and that's going to be determined after the Alpha Model is built. We don't know what it's going to do. We know it's going to be way more efficient than this thing is. This was custom built by people that wasn't engineers. The Product Design Experts is the guys that does Caterpillar, DeWalt. There's a couple other big name guys that they do work for. And they told us that this machine is going to be phenomenal when they get done with it as far as efficiency. We're talking, instead of pillar block bearings, we're talking magnetic bearings. You know what I mean? The less friction, the better. And if the engineer is watching this, he knows exactly what I'm talking about. There's a lot of friction loss that goes on in this machine. Okay, the machine that they're building for us, we're trying to eliminate every friction loss possibility, even heat loss. We don't even want no heat loss in this machine because, as you all know, it's more efficient when you do away with those variables, okay? So that's our goal in alpha model, is for one, make it lighter, make it way more efficient, okay? Which I kind of like. I like being secluded. This is perfect for this. If somebody was to do like secluded research, say if we were out in the middle of a jungle somewhere and we needed power to power up our electron microscopes to do research in the middle of nowhere, we can do it with EcoMech 1. That's just one of the many examples that I could give on the usage of this machine. You know, I'm looking into maybe even powering boats with it, powering, you know, so that you don't get stranded out in the middle of nowhere. You know, you got an electric motor, you wind the machine up, it creates electricity, now you're not stuck anymore. You know, so I don't know, just a lot of different things we could do with this machine, you know.